All right, let's take a look at our third example, and this is coming from the homework problem. And I picked out this problem because I want you to feel comfortable with how the problem on the homework is laid out. So basically, we are still gonna do 4 steps, but they didn't label step 1, 2, 3, 4. They just kind of put it into like all these small little parts. Okay, but you can see that the first few problems, domain question, x-intercept, y-intercept, horizontal, vertical asymptote, these are all step 1. So this part is all step 1. This part, interval increasing local extrema, that's a step 2. And then further down, concavity inflection point, that's step 3. And then the graph will be step 4. So it's same thing. Okay, it's just it's in the multiple choice rather than whole free response. So let's start with our domain. Take a look at our function. Our function has 2 parts being multiplied. The quadratic square is a parabola and then ln. So you have to know a little bit about characteristic about these graph. Parabola is all real for domain. ln, we do have a restriction. ln graph, it's only defined from 0 to infinity. So our domain is, so the best answer is second one. We do have a domain restriction, and then our domain is 0 to infinity because of ln. So let me highlight that. X-intercept, so we are going to let y equal 0. So let's solve. If I let y equal 0, so that will be 0. 0 equal to 10x squared times ln x. And then I can divide it by 10 because that's a constant. So 0 is equal to x squared times ln x. By zero product property, I can set one factor equal to 0 and second factor equal to 0. Here, if I square root, I'm going to have x equals 0. Now, very tempting, but take a look at domain. 0 is not included. So actually, we exclude that value. So there's a domain. Do not include that. 0 is not in domain. ln of x does have equal to 0. That's when x equal 1. 1 is okay because it's in the domain. So we do have x-intercept. They occur at x equal 1. Okay, so let's also highlight that. Y-intercept will be the opposite. So let me move this one over here. Y-intercept will be when x equals 0. So I'm going to plug it in. For y-intercept, we let x equal 0. So 10, 0 square ln 0. So that will be... actually, in fact, 0, well, you can kind of see that this ln 0 is an issue. We cannot have x equals 0 because that's not in the domain. So we will not have y-intercept because it's not even valid to consider x value equals 0. So no y-intercept. Okay. Horizontal asymptote is when the limit of x goes to infinity of our function 10x squared ln x. Now, if you plug it in infinity here and infinity here, I'm just going to get very, very big infinity. So that means there's no actual value. So there is no horizontal asymptote. There's no value. It's just really big number. So no horizontal asymptote. Okay. And then let's keep going. Vertical asymptote is when undefined value. In this case, we do not have an undefined value because it's not a fraction. So we will not have a vertical asymptote. Okay. Step 2, increasing, decreasing, and then also local extrema. So for that case, I need to find the first derivative. So let's apply the first derivative. Now, our first derivative, this is our original one. That's a product rule. So this one, let's take the derivative of this first term. So that's 20x. Second term remains the same. Plus 10x squared. Derivative of ln x is 1 over x. So in other words, 1 over x. So I can keep going and then see that this cancels out. So I'm going to have 10x. So I see that they both have a common factor of 10x that I can pull out and have 2 ln x plus 1. So that will be my first derivative. And I'm going to set that equal to 0 because that's where the critical value occurs. We do not, right? So there are f prime 0 or f prime does not exist. We do not have to worry about where it doesn't exist because it's existing everywhere. In other words, there is no vertical asymptote, no undefined values. So I cannot find anything from here. If I set this one equal to 0, I'm gonna have 10x 2 ln x plus 1 equal to 0. So by zero product property, 10x equals 0, 2 ln x plus 1 equals 0. Now, again, same issue. We do have a number, but 0 is not included in the domain. So we don't include it. Let's keep going. -1, -1. 2 ln x equals -1 divided by 2. ln x is equal to -half. The only way that we get rid of the ln is apply e function. So if I apply e function, I'm going to have x equal to e to the -half. So that will be using the calculator, rounded to the 2 decimal place because it's asking you to eventually round it to the 100th place. I'm getting 0.61. So there is one possible critical value, 0.61. Okay, and then let me use my number line to check. So 0.61 f prime of x. Let's check and see where the function is increasing and decreasing. So we have 2 test region. Number 1, the test number that I'm going to use. Remember, we have a domain restriction 0 to infinity, so we cannot pick 0. Okay, so I'm just gonna mark it 0 and on. So I'm just gonna put 0.5 because that's smaller than 0.61. Number 2, test number that I can use, anything bigger than 0.61 works, so +1. Okay, let's plug it into our first derivative function, which is right over here, this part. Okay. So f prime of 0.5 is 10 times 0.5, 2 ln 0.5 plus 1. Putting everything into a calculator, I'm getting -1.93. So that's a negative value here. Let's plug it in. F prime of 1 into this one. So 10 times 1, 2 ln of 1 plus 1. Putting directly onto a calculator, I get positive 10. So in this case, we have a decreasing and then increasing. So decreasing at 0, because remember our domain started at 0, to 0.61, and then increasing on 0.61 to infinity. This one is our critical value, our sign switch, decreasing to increasing, so it looks like local mean at x equals 0.61. So I'm gonna copy all this and then answer the next two questions. This is what we found. So let's put it in. So I have, first question is increasing, decreasing. So I have increasing right over here, right there. Let's resize to fit it. And then decreasing right over here. Okay. And then let's highlight it. And we do have a local minimum, and no local max at x equal 0.61. Okay. Okay, so we are done with the step 2. Let's go to step 3. Step 3 is a concavity. So step 3, take a second derivative. So second derivative. Now our first derivative ended up being, I'll just use this format because it's easiest one to integrate. First derivative end up being this. So my second derivative, this part needs a product rule. So it's gonna be 20 and then ln x, and then we switch, right? 20x, and then derivative of ln x will be 1 over x. Derivative of last term 10x is just 10. Let's simplify further. So 20 ln x, x cancels out. 20 plus 10 will give me 30. So that's my second derivative. Now, second derivative, let's find the inflection point. Two possible scenario. You know that this is existing everywhere, so we eliminate that. So the only possible way that we can have inflection point is this part here. So let's set the second derivative function equal to 0. Subtract 30. 20 ln x equal negative 30. Divided by 20 ln x equals negative 3 over 2. Same thing, the only way to get rid of ln x is apply e function. So we have e raise it to negative, x is equal to, if I apply e function, this part disappears. X equals e raise it to the negative 3 over 2. In a decimal value, rounded to the 2 decimal place, I get 0.22. Okay, so that is my possible inflection point. Let's use test point. So I have for region 1, the test number I can choose. Again, remember we have a domain issue, 0. So I'm going to pick 0.1, and then test number. For the second part, I can choose anything bigger than 0.22, which is positive 1. So f double prime 0.1, I'm gonna plug it into right over here, this function, 20 times ln of 0.1 plus 30, which is equal to negative 16.05 on the calculator. So I get a negative f double prime of 1, I get 20 ln of 1 plus 30, so I get positive 30. So we have a concave down, concave up. This, because we change our concavity, this is our inflection point. Now let's do that. Concave upward, right over here. That will be 0.22 to infinity. We do have a concave down, which is at 0, 0.22 right over here. So this part I'm gonna highlight right over here. Inflection point at where? 0.22. X equal 0.22. All right, let's use all this information to check and see which graph is f of x. Now, automatically, I know a and b, I can eliminate it even without thinking. Why? Remember, our very first part, domain is 0 to infinity. This one has domain everywhere, right? So it has to be either C or D. Notice that open circle because we don't include 0. So let's take a look at this one over here. Now, you know that 0.22, so 0.22, if this is, let's see, let me use this one, the one that we found. Okay, and compare with this. 0.61, so 0.61 is right over here. That looks good. And then 0.61 right over here. Good. Now, we first have a decreasing function. Decreasing, and also around 0.22 we have a concave up. So first region I have a decreasing and then concave up. So decreasing, concave up. I should have, oh, I'm sorry, that's a concave down. Concave up means a parabola. That's this part here, decreasing and concave up. So automatically, you know that if I'm having this one, the only thing that is having this shape here is the D right over here. This is upward. This is concave down and increasing. So my final answer will be letter D. Okay, that's it for section 4.4.